Okay, so to continue on, I'm sorry I had to break that last video and do this in pieces. There are ways to find the focus in directrix, but what you really want to do is just find another point to help determine a good shape of the parabola. Like if you fill in 0 for x, you get 4 for y. And so if I fill in 0 for x and get 4 for y, I have my vertex at 2, negative 4. I have another point, and I can count on the symmetry of this, and I can draw a good parabola this way. Alright, so on number 3, let's decide what this is. Is it a parabola, an ellipse, a circle, or a hyperbola? Alright, since two things are squared, parabola's out. Since it's minus, it's a hyperbola because they're going to get away from each other. So this one is a hyperbola. We may talk about the foci in a minute, but the big thing when you're looking for the center is the first thing I find is the center. The center, look at what letter it's paired with as time goes on in this video. So you're treating it like a factor, like what makes it 0 would be 2 and 1. And so I graph as I find things, 2, 1. Now, hyperbola is really weird, so I'll show you how this works. I'm going to count the square root of 9, which is 3, and I'm going to count across since it's under the letter x. So I'm going to count out 1, 2, 3, and back 1, 2, 3. This I'm going to count up 4 and down 4 because it's under y and it's a 16. Square root of 16 is 4. Up 4 and down 4. If it was an ellipse, I would then join them into an ellipse and go about my life. But since it's a hyperbola, you do this weird thing. You make a box, go through all of your points, and then connect the corners in these weird asymptotes. That you could actually find the equation of the asymptotes, which I don't require you to do right now with this quick lesson, but you could write them. These asymptotes are y equals mx plus b form. Now you have to decide, are you going to do your hyperbola from these dots and follow these asymptotes? Or are you going to do your hyperbola from these dots and follow these asymptotes? It's easy to decide which one it is. It's whichever one comes first. Since x is first, it's going to be the ones that I drew at first. So what you do is you look back at your hyperbola, and since x comes first, you go to these ones where you went out 1, 2, 3, and you put your dot on that line, on that dot, you put your vertex, and then you follow your asymptotes away. So don't draw it like this. The asymptotes are there for a reason. Alright, so you could name your vertices because you found them yourself. So you were at 2, 1, and you counted out 3, so now this is 5, 1. And this one back here is negative 1, 1. I'm not making you name the asymptotes. Also won't get you to name the foci, but for argument's sake, what you do, the foci pull the hyperbola toward it, and the further away, the more it changes the shape of the hyperbola if you played around with it in an application like Desmos. What you do if it's a hyperbola is you add these instead of subtract them. You add these two numbers and you get 25. Then you square root that number, and so you're going to count 5 from where? In this direction right here. So you're going to count in this direction from your center. So you're going to go 1, 2, 3, 4, 5. And you'll go 5 in this direction, and those are your foci, and they help determine the shape of your hyperbola. So in this case, if I had to name my foci, this one I counted from 2, I counted out 5, so it would be 7, up 1, and then I counted back 5 from 2. I kind of missed it. It would be right here instead. because 2 minus 5, this 2 right here, 2 minus 5 is -3. This looks kind of funny here looking at this. Remember our center was 2, 1. I think I've drawn on that a lot. Alright, this one, I think the answer sheet kind of missed this, if this is the one that they got incorrect. Let's see. So we got this, and we got this, and we got this, and you're not having to name the asymptotes. We got this picture, and these are really your vertices, and they named these minor vertices. Those are not really your vertices. Your vertices would be where this bends. So I would count on ours, which would be 5, 1, and -1, 1. Did I write that wrong? Now I'm thinking I wrote -3, 1 because I was counting back. I don't know. We'll check. Yeah, I got it right here. Alright, now we're writing the equation of a circle. Equation of a circle is x minus h squared plus y minus k squared equals r squared. This goes with x, this goes with y. So it's x minus -5 squared, y minus 10 squared. And so I need the radius. Draw lots of pictures in calculus to decide what is happening. And so I'm going to go -5, 10. And that's my center. It's tangent to the line x equals 8. So that means my circle's coming around like this and skirting along, and it's tangent right there as it goes around. So I know the radius of it. This is 5, and then I went 8 more, and so the radius is 13. So the equation is x plus 5 squared, y minus 10 squared equals 169. And I think throughout this I'll just check my answers to make sure that I don't make a careless mistake. Let's see, what number was that? There we go. Okay, so now let's go to number 3. Alright, this is a circle. Let's talk about y. Two things are squared. It's plus, and the coefficients are the same. So this is a circle. The center of the circle, watch your variable. X would be -3, and your y component would be 1. The radius is the square root of 9, which is 3. So you go to -3, 1, and then you're going to radiate out 3. 1, 2, 3. And 1, 2, 3. And you can see there's also polar graphs that would do these things, and later on parametric graphs that would do these things. And so we'll learn also on another worksheet that you do over the long weekend or before class, next class that we have. We can also, this is in rectangular coordinates, we can also make this happen in polar coordinates. Number 6. Alright, now before we decide on this parabola, I've got to decide which way it's going. And so I have 2, 3, 4, 5, 6, 7, 8. The directrix is a line that is behind your parabola, so this one's going this way. Okay? There's a whole lot of different ways to do this, but I'm going to do it, since it's going this way, it's not a function. So we have this formula, x equals y minus k squared plus h. Your y components are always paired together. Alright, a is going to be negative in a little while, but what I know is my vertex, notice this is the y, so it's y minus -8 squared, and this would be out here. Then I would maybe find a point and fill it in to find a, but that's as far as you need to take it, not really needing to know what the directrix is. On the AP exam, they'd give you like another point or something that you could fill in for x and y to find that coefficient. You wouldn't have to know the word directrix, even though it is important for algebra. And so they got it to be -1/4, but you're not having to do that right now. You can see the picture right here, and we've gotten that far. So you don't have to know how to deal with directrix and focus foci. Alright, now this one, let's talk about what it's going to be. Parabola, ellipse, circle, or hyperbola. Alright, not a parabola because two things are squared. It's not a hyperbola because it's a plus sign. So it's an ellipse because the coefficients are different.